All right, Algebra 1, section 5.3. This is the lesson. And let's see if we can fix this a little bit. The topic is solving systems of linear equations, which is what we've been doing. Now, this is the third section, straight section, but we're going to learn a new method called elimination, by elimination. So that's the title. Write that down. Write your name. Write a period. Write the date. Let me turn this in. Okay. So the big idea here, sort of the big strategy, the big idea is that we're going to multiply by any number to get opposites. That's the big idea. Multiply by any number to get opposites. So opposites, up, down, left, right, as far as numbers go, if you had a positive 5, the opposite would be a negative 5. And when you add them together, they cancel each other out and they go away. So that's sort of what we're trying to set up here. So step 1, multiply if necessary. Sometimes it might be nicely set up for you. Multiply if necessary one or both equations. There's going to be two equations. So the system is one or both equations by a number, so you have opposites. So we're trying to set this up. So that's step 1. Step 2, add equations to eliminate one variable. That's why this is called elimination. Eliminate one variable. Now, with substitution, we would eliminate one variable also by substituting one equation in the other so that everything was x or everything was y. So step 3, solve. Solve for the variable that's left. Step 4, substitute to find the other variable. And this last step is pretty much the same, kind of the same thing as the last step on our last section. So, if you ever need to, pause the video so you can get this down. So we're going to try some examples now. Example 1. Let's see, I'll try and take up like half the page. I'm going to try and fit 4 examples here. Example 1, 3x plus 2y equals 4. 3x minus 2y equals negative 4. These are going to be nice to write above and below each other and line everything up. So the first step, multiply if necessary one or both equations by a number so you have opposites. Now if you look here, we already have opposites right there. Positive 2, negative, positive 2y, negative 2y. They're opposites. If you add them together, they cancel out. The x's aren't opposite. You'd have to multiply one by a negative, which you could do, but why would you waste what they have here? So we're going to add these together. Step 1 is pretty much done. It's already ready to go, or sometimes it will be that nice. But then you're going to add the equations. You're going to add all the like terms on each side. So 3x and 3x is 6x. These cancel each other out. There's nothing left. This gives you 0. And then now you just have one variable. You just have x, so now you can find x. And you get x equals 0. That's half of your answer. You need the y value still. So now are you going to plug this back into either one of the first equations? Doesn't matter. To find y. Now, I look at which one's going to be easier to get y by itself. They're both pretty close, but this one has this negative in front of the y that I don't really like. So I'm going to plug this back into the first equation, but you can do the second equation. It'll give you the same answer. So I'm going to plug it into the first equation. Wherever I see x, I'm going to put parentheses 0. And then I'm going to solve. Now, 3 times 0 is 0. That goes away. Right? Okay, so then we can divide by 2 to get the y by itself. Solve for y. Now, these are answers like they've been in the last two sections. X first, y second. X first, y second. For your final answer, it's an ordered pair in parentheses. Okay, so the first step, we didn't have to multiply. It was ready to go. Number 2, we added the equations. Then we solved for x. Then we substitute that into one of the other equations to find the variable. Let's look at another one. I'm going to slowly make these a little harder as I go. You'll get some this easy, but okay, this one, the equations are negative 10x plus 3y equals 1, and negative 5x minus 6y equals 2, 23. Okay? Now here, if you look at these, the numbers aren't opposites yet. Negative 10, negative 5 aren't opposites. 3 and negative 6 aren't opposites. Now, we can multiply one equation to make the numbers the same, but have to have opposite sides. So we can multiply this whole second one by negative 2 and then give us positive 10 here. That'd work. Or we can multiply the first equation by 2 to make this positive 6 to cancel out with the negative 6. Now, I like to avoid the multiplying by extra negatives whenever I can because I know I'm more likely to make mistakes with it. So I'm going to choose to multiply the first equation, both sides, by 2. Now, you're allowed to do this in math, right? Multiply the side of an equation by some new number as long as you balance it out and do both sides. So I'm going to multiply both sides. I'm going to get negative 20x plus 6y equals 2. So I've changed the first equation. The second equation I'm going to leave alone because it's ready to go. So now I'm going to add these together, and the y's are going to cancel each other out. Like I said, you could multiply the second equation by negative 2 instead. That would have worked. Now this is going to be negative 25x, and this is going to be positive 25. And we got to keep going and solve. Divide by negative 25. It's being multiplied, so you got to undo it by division. And we get x equals negative 1. That's half your answer. Now, I'm going to plug this back into either of the first equations. I don't really want to do my new one because it has bigger numbers than it needs. Now, if I'm looking at y, I feel like this y right here is going to be easier to get by itself. So I'm going to plug this x into that x right there. You could use the second equation. It would work. But I'm just trying to be smart about it. So negative 10 times negative 1 plus 3y equals 1. And I'm doing the version before we multiplied by 2. You can do the version after you multiplied by 2, but the numbers are bigger, which makes it a little harder. Negative 10 times negative 1 is positive 10. So then I'm going to subtract 10 from both sides. Now we're solving reverse PEMDAS, reverse order of operations. Do addition and subtraction first. Then multiplication, division, divide by 3. Y equals negative 3. That's the other half of your answer. Now we're always going to write our answers as ordered pairs. So it's going to be negative 1, comma, negative 3 in parentheses. Now we could check these answers just like we've been checking them since section 5.1. Just plug this into both of the original equations and see if it's true. Plug the x and the y in at the same time into that one, see if it works. Plug it into that one, see if it works. You can check your answer that way. All right. Let's try another one. Example 3. So this one's going to be 2x plus 3y equals 7. And 3x plus 4y equals 10. Now, the first example we didn't have to multiply either equation. It was ready to go. Last example, we had to multiply one of the equations to make an opposite. This one, we're going to have to multiply both equations by numbers to make them opposite. There's no way of just multiplying by one and getting opposites. We can make the x's become opposites, or the y's. I think I'm going to just go with the x's. The number's a little smaller. Doesn't matter. We got to multiply one of them by 3 to make it a 6, and one of them by 2 to make it a 6, right? But we need one of them needs to be positive, one needs to be negative. It doesn't matter which one. So I'm just going to decide to make the second one negative. Okay, so if we do that, we get 6x. If we distribute this, 6x plus 9y equals 21. Make sure you multiply both sides. People forget the other side. And then I multiply the second equation by negative 2. It gives me negative 6x minus 8y equals negative 20. And now, you'll notice we have opposites right here, and they're going to cancel each other out. We could have got the y. We could have multiplied the first equation by 4 and the second equation by negative 3, and we would have got rid of the y's instead. Doesn't matter. You add these together, you get y equals 1. Right? Positive 1y equals positive 1. That's half your answer. Now, I want to find the x. I can plug this in either of the first equations. I personally like the first one because the numbers are a little smaller. I'm just looking for what seems like a little easier work. It doesn't matter which one. The work would almost be the same. So 2x plus 3 times 1 equals 7. And I'm doing it with the version before I multiply the numbers in because, again, it works to be easier with smaller numbers. So this is going to be 2x plus 3 equals 7. You got to get rid of addition and subtraction first. Subtract 3 from both sides. 2x equals 4. Divide both sides by 2. X equals 2. Final answer, 2, 1 in parentheses. Okay, you can check it. All right, example 4. The problem is x minus 3y equals 24, and 3x plus y equals 12. Now, what I want you guys to do is to go ahead and pause the video and try this problem yourself. Let's see if you got the hang of it. It's going to be a lot better if you try it now before you start working on your own. So pause the video, try this problem, see what you get, unpause it, and you can see how you did. All right, assuming you guys tried it. Now the way I do it might be different than the way you did it, but we should still get the right answers. You know, there's multiple ways to do it. Do you want to get rid of the x's or the y's? Now, I think we could just multiply one equation, first of all. But this one already has a negative and a positive. I feel like I want to take advantage of that. If I don't, then I got to multiply the whole first equation by negative 3, and I just feel like I'm more likely to mess that up. Otherwise, I can multiply the whole second equation by just 3, because the positive and negative things are already set up. So the first equation is going to stay the same. X minus 3y equals 24. I'm going to rewrite that. And then the second equation is going to be 9x plus 3y equals 36. And now we have opposites right here. So if we add these together, add, those drop out. This is a 1x, so that's 10x equals 4 plus 6 is 10, carry the 1. 2 plus 3 is 5, add the 1 is 60. Divide by 10. Now you didn't have to do it this way. You could have, like I said, got rid of the x's and found the y first. It'll be the same answer I get eventually. I want to find y. I feel like the second equation is the easiest one to solve for y because it doesn't have any number in front of it, and it's also positive. So you can do either one. It'll give you the same answer, but you might try and choose the one that looks easier. 3 times 6 is 18. So now we're going to solve, subtract 18. Y equals negative 6. So your answer is 6, negative 6. X first, y second. That's it. So today's classwork, monitoring progress. Starting on page 249. Problems 1 through 3, all. These are all on the bottoms of the pages. So in the middle of the unit, if you're using the Student Dynamic ebook online, there's little blue arrows. You got to be zoomed out, I think, all the way. If you play the little blue arrow, it'll give you a video showing you exactly how to do the problem from beginning to end. So you can use it to help you figure out why you got it wrong, where you're getting stuck. Check your answer real quick. And that's it. Just 3 problems. So let's see if we can get it done.